Hello everyone. In this video we are going to create an isometric game template or prototype using Panda3D. So the end result, or one of the end results, will look like this. We have this isometric map, and we can also hover over with our mouse and it detects on which tile the mouse pointer is, using raycasting. And we are also going to implement something like the isometric movement using this cube, so we can move right, left, up and down on the map. And in the second scene, what we are going to implement is, so now as you can see, these are just flat planes in the 3D world. And in the second scene, what we are going to implement is this one. So we will have 3D geometries and also in isometric view, and we can also, or we will be also able to detect the mouse hovering. And as you can see on the left side, it prints which tile we are hovering with the mouse. So this is tile 1, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and here it starts with 10, 11, and so on, up until tile number 99. As usual, I'm just going to start with a base template already coded out. So the first thing we have to do is import the showBase class from the direct.showbase.showbase module. The next thing will be to import the load.prc file data from the Panda3D core module. Here I'm just created config variables or config vars, which is a multi-line Python string. And here in this config vars I'm setting two variables, config variables. One is the window size or win-size. So the window will be 1280 by 720. And also I'm just setting the frame rate meter to 1. So if I run it by right clicking, we have a 1280 by 720 window, and also in the upper right corner it shows the frame rate meter, so it runs on 60 FPS. So here on line 9 we are just using the load.prc file data and loading the config variables. And the first argument to this function is just an arbitrary string, and it can be empty. So the next thing here, I'm creating a class, and I'm just going to rename it to isometric game. Like this, isometric game. So the isometric game will inherit from the showBase class we imported here. So every Panda application have to inherit the showBase. And in the init method of the isometric game class, we are just going to call the super classes or the showBase classes init method. And this will initialize all the variables and methods from the showBase class. Here on line 15, I'm just setting the background color of the window to black, so red, green, blue, and alpha. And here I'm instantiating a game object from the isometric game class. And on line 19, I'm just entering the main application or the game loop with the command game.run, so by calling the run method. So I already prepared here in the isometric folder an egg folder, and it contains one egg file, which is the plain.egg. And it also contains a second folder which is named text, and this text folder contains the texture what we are going to use, and this is this texture, so brick-c, which means colored.jpg. so this is just a simple JPEG file, and this is what we are going to use to actually texture the planes. Okay, so let's load this plane, and as usual, to save time, I'm just going to copy and paste the code from my second monitor. So using the self.loader.load model, I'm loading here it is called egg models, egg-models, and loading the plane.egg file. So this file, plane.egg. The second thing will be to actually create a texture. So self.text1, or name it as you want. I'm just going to name it text1 using the self.loader.load texture, also from the egg-models folder, and inside there is a text folder, and inside the text folder there is the brick-c.jpg file. And lastly, we are going to just set the plane's texture to self.texture1 or text1. So let me take a look what we have. So I'm just going to reparent the plane to the renderer. So reparent to self.render, and if I run this and I move the camera back, I will see a textured flat plane. So, but I'm just going to comment out this line, but because we are going to use actually a for loop, and using the instantiation, I already created a video in my basic Panda3D series about how to do instancing. So using the instancing, I'm just going to create a grid of these planes. So to create the grid of planes, I'm just going to create a method here called create map, or we can also call it create grid. And it takes two arguments, the width of the grid and the height of the grid. So how many tiles are in the width and how many tiles are in the height of the whole map. So the first thing in this method, I'm just going to create a local variable called counter, and two nested loops. The first loop will be the for z in range height, and the second, which will be nested inside this loop, will be the for x in range width, and just give it a pass for now. So for z in range height, this will create the planes vertically, and for x in range width, this will create the planes horizontally. Okay, and now we are still missing one step, which is just create an empty notepad, and I'm just going to name it here in the init method of the isometric game. I'm just going to name it self.mymap, and using the self.render.attach new node iso and giving it the name iso map, this will create an empty notepad, and it will attach it to the renderer. Okay, so let's go back to this method, and the first thing in every iteration of this nested for loop, I'm just going to create a local tile variable using the self.mymap.attach new node. So we are attaching in every iteration of this second for loop or nested for loop, we are creating a new node, and we are attaching this node into the my map. So tile equals self.mymap.attach new node, and the name of this new node will be the tile dash and the counter. So the counter, we are going to increment the counter in every iteration. So in the first iteration it will be tile dash 0, in the second iteration it will be tile dash 1, then tile dash 2, and so on and so forth. The next thing is setting the tile's position, and remember that this mymap self.mymap.attach new node, it will return a new notepad which we are saving in this tile variable. So we can call on this notepad the set position method and setting its position to X, 0 and Z. And let's do the instantiation. So we are going to create a new instance from the plane we loaded here, and self.plane.instance2 to the tile. So it will create a new instance in the position of this tile. And here I also added a comment. So first we have to create an instance, and after this we can set the bit mask, and the bit mask we are going to use for the mouse hovering, so to actually detect on which tile we are hovering over with the mouse. So in the next line we are just going to set the bit mask. So tile.find the plane and getting the node and set the into collide mask to bit mask 32.bit1, and we also have to import the bit mask 32 from Panda3D core. Okay, so and the last thing in this create map will be just incrementing the counter, local counter variable by 1. Okay, so let me try this out. I'm just going to call after this line the self.create map, and the map size will be 10 by 10. Okay, now run it. Move the camera back, and now as you can see we have a grid, a big map. So 10 tiles horizontally and 10 tiles vertically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see where the image, so the seams of the image. And don't forget that you have to call the self.create map after the my map is created, because it relies here in the body of this method, it relies on the self.mymap. And if you want to create, if you want to use other dimensions for the grid, you can just change the width or the height. Let's say I'm just going to change the width to 5 and the height I'm just going to change it to 20. So, and now if I run it, we have a different grid. So width is 5 and the height is 20 tiles. So to create an isometric view from this scene, now we are just seeing this plane or this grid of planes straight up, down. So to actually look at this plane as in isometric camera angle or view, we just have to move the camera to the proper position. And here I just opened up Blender, and we have, I just created the same scene we have in Panda. So we have a big plane or a grid of planes. We have the camera which starts in the same position as the grid. And there is some steps to actually create an isometric view of this plane. The first step is just we have to move the not the plane, but the camera, we have to move it back. So let's do this first. Back on the y-axis. So let me see, go back here, and I don't know where, I'm just here, I'm just going to, after setting the background color, I'm going to set the camera's position to 0, -6 and 0, so this will move back the camera on the y-axis. So now we are seeing part of the grid. The next step should be to actually set the camera's roll to about 45 degrees, and the roll is the rotation around around, let me see, roll is the rotation around the y-axis. So let's rotate this camera around the y-axis. So rotate y and 45 degrees. So now we rotated the camera 45 degrees on the global y-axis. Now if I go to the camera's view, here we are seeing the corner of the grid. So let's do this also in the code. I'm just going to copy from my second monitor and go back to here. And here we set the position of the camera. Then we are going to set the set the roll to 45. So now if I run the application, we are seeing the same corner as we are seeing here in Blender. Okay, so let me take a look on the next step, which will be actually rotate the camera on the pitch, but this time not on the global axis, but on the local axis. So let's do this in Blender first. Okay, let's go into this view, and to actually rotate something in Blender on its local axis, you have to go and switch this from global to local and switch this to rotate. And what we are going to do is actually rotate it, but it still rotates around. Okay, now it is set to local rotation, and we are going to set the rotation on the pitch, which is the x-axis. And if I grab this red handle here, and hops, and I'm just going to rotate it about 65 degrees. Here in the upper left corner it shows that rotation is 65 local. So here it showed before. And now what we have, let me take a look, let me go to the camera's view. Now we see the other corner, the end corner of the grid. So it is actually close to the isometric view. So let's do this in code also. I'm just going to copy the next line and paste it here. And if you want to set a local rotation, you have to give it the camera. So we are going here, we are setting the camera's global position, or I mean global rotation on the roll. So if you just call it like self.camera.set R, which is the roll, and with a value like this in 45, it means that it sets the global roll rotation. If you use the set R or P or roll, pitch and jaw, so set J, and if you give it the camera as a first argument and then the degrees what you need to rotate, then it will rotate around its the camera's local axis, like I showed you here in Blender. So now if I run the game or the template, so I also added here some comments that set camera local pitch rotation. So let me see, and now we're seeing as in Blender this part of the grid. So the last step will be actually just set the camera's position back on the local z-axis. So if I select here the camera and I'm going to tap G and Z twice in Blender, it will move the camera on its local z-axis, not the global z-axis. So I have to move back the camera, and as you can see now I'm seeing the whole grid in isometric view. So let's do the same in the code. Okay, just copy and paste it here. So self.camera.set position, and because we want to set the position on the local axis, we have to give it first as a first argument the camera itself. So self.set position self.cam, and then we are going to get its current position, and we are going to add to its current position a vector 3 and x, y, z. So negative, we are going to move back -4 units on the local z axis. So let me import the vector 3 from Panda3D core. And now if everything went okay, I'm seeing my grid in isometric view. So this is very useful to actually open up Blender sometimes and just figure out in Blender how you want to place your cameras, your objects, and so on, and then it is easier to actually implement this in code. So let me take a look one more time on the code. So first we set the camera's local, we set the camera's global position on the y-axis -6. Then we set the camera's roll on the global y-axis, so roll rotation is the y-axis, to 45 degrees. So set camera global roll rotation to 45. Then we are setting the camera's local pitch rotation just by giving here the self.cam, so it means that it is local, to 65 degrees. And lastly, we are setting the camera's local position to camera's current position plus a vector 3 of 0, 0, -4. So it will move back or up the camera on the z-axis -4. Okay, hopefully it was understandable. If you want to actually learn about this a little bit more, you should also just download Blender and do it yourself in Blender as I showed you. So now that we have our isometric our map in isometric view, the next step will be to actually add the functionality to detect the mouse hover. So as I'm going to move my mouse over the grid, it will show which cell of this grid or tile of this grid is under the mouse pointer. So for that we will need a few more imports, and I'm just going to copy this from my second monitor and paste it here. So from Panda3D core we are going to import the collision traverser and also the collision node. And I already imported here the bit mask, so I'm just going to delete this. And the next import will be also from the Panda3D core. We are going to import the collision handler Q and the collision ray. And I also imported the vector 3 here on this line. So okay, collision traverser, collision node, collision handler Q, and collision ray. If you want to learn more about this stuff, you can read the documentation, the official documentation of the Panda3D. Okay, so here, after this line, I'm going to create a collision traverser, and I'm just going to name it picker, because we are going to do mouse picking. So self.picker equals collision traverser. Then we are going to create the queue using the collision handler queue. So self.queue equals collision handler queue. The next step will be to actually create the collision node. So I'm going to name it picker node, and we are going to use a collision node class and give it a name picker-node. The next line will be to actually set the from collide mask. So the picker node, we are going on the picker node, we are going to set the from collide mask to bitmask 32.bit1. And here in the create map, if you remember, we already used this line. We set the into collide mask to bitmask 32.bit1, and here we are also setting the picker node to bit 32.bit1, but here we are setting the from collide mask, and here we are setting the into collide mask. Okay, now let's create a picker node. I mean a picker notepad. The picker node is already created, so I'm just going to name it picker_np. np stands for notepad, and using the self.cam that attach new node. So I'm just going to attach this notepad to the camera. So self.cam.attach new node and the picker node. And on the next line, I'm going to create a picker ray using the collision ray. So as I said earlier, we are going to use ray casting to actually detect that the mouse pointer is on which tile is the mouse pointer hovering. So let's do the next step. And here on the picker node, we are going to add a solid, which will be the picker ray. And lastly, we are going to add to the picker, using the add_collider method, the picker notepad, so this one, and the self.q. So let me see if there is an error or not. I'm just going to copy one more line, which should show the collisions. So self.picker.show collisions and self.render. Now let me see. Yeah, it doesn't show. I'm just going to comment this out and later comment it back. I mean, yeah. Okay. So now we have prepared all the collision handlers and the collision traversers and collision nodes and collision notepads and the collision ray. Okay, so the next thing will be to actually create a function, and I'm just going to name it something like mouse task. Okay. So it will be the mouse task function, and as a second argument it will take a task. And of course, in order to actually call this mouse task method every frame, we have to return the task.count, which means task.continue. So it will ensure that this method will be called in every frame. And the next step will be to actually add this to the task manager, this method. So here, after these settings, I'm just going to add to self.taskmanager that add the self.mousetask and just name it self-mousetask. I just like to name it like this, mouse-task. Okay, so because we are added it to the task manager, this method, I can print out something to the console like hello, and if I run it, now as you can see it continuously prints out hello, 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 so 60 times in a second. So which means this task is working as expected. So here in this method, the mouse_task method, as I'm going to add as a first line a condition which will ask if the mouse pointer is inside the window. So self.mousewatcher node that has mouse. And if I'm just going to print something, so print inside inside. So if I run it, when the mouse pointer is outside the window, this evaluates to false, and when the mouse pointer is inside the window, as you can see here on the lower left, it prints inside. And now it doesn't print. So okay, we need this, because otherwise if we move out the pointer from the window, the application will crash. So inside this if statement, I'm going to add the next line, which will be the mouse position. I'm just going to name it mpos, using the self.mousewatcher node.getMouse. And let me print it out also. Print mpos, and let me run it. And this returns up on LF or L pointer to F with the mouse position inside the window. And this ranges from -1 to 1 on the X and also -1 to 1 on the Y axis. Okay, let's remove this print, and I'm just going to set, using the set picker or the self.picker array, the set from lens, camera lens, so camera node. We are going to use the camera node's lens, and this camera node is actually inherited from the show base class. Okay, so self.picker array, which is this collision array object, that set from lens, camera node, and the mouse position that get X and the mouse position that get Y. So X and the Y position in the window. Okay, the next line will be to actually traverse the map. So self.picker, which is this collision traverser that traverse the my map, which is this ISO map. So at default, this is just an empty notepad, and here in the create map method we are filling this empty notepad with those styles. Okay, now let's do the second nested if condition. So if the cell.q that get num entries, this returns how many collision entries are inside the queue. So if it is bigger than 0, then it means that our mouse is hovering over a tile. In this case, I'm just going to copy one line here in this if condition, which will just sort the collision entries. So yes, I'm just going to copy this also, these two comments. If we have hit something, sort the hits so that the closest is first and highlight that node. So okay, sorry, it is a bit slow because I think the pandas, this collision detection is a little bit, I think, overcomplicated. I mean, I use several game engines like, I don't know, Arcade or Godot or Unity, I don't know, and it was never so complicated than it is in Panda, so you have to get used to it. So let me check if I'm going to uncomment this line. Let me check if it is now detecting the. Okay, now as you can see, it detects on which tile we are hovering over. So to actually see this collision, you have to use, I mean not the collision, but actually this stuff here. You have to actually do this line, cell.picker the show collision, cell.render. Without this line, it won't show. Okay, I'm just going to comment it back. Okay, so here we are sorting the entries, the collision entries, and now to actually getting the tile using self.q that get entry at 0, that get into notepad, that get node 2. And let me print this out, what it prints. So tile. Okay. And it prints out Panda node tile 16 or Panda node tile 3. So we are getting the correct tile. And let me get also the tile index. So the tile index will be the tile that get name, which will return tile 1 or tile 3 or tile 16 or tile 0, depending on which tile we are hovering with the mouse. And here, as you can see, it returns a string like this, tile -0. So we are going to split it by the dash and getting the tile, which is the number after the dash. And if you remember here in the create map function, when we created the tiles, we added their names as tile, dash, string, and counter. So first iteration it is tile -0, the second iteration it is tile -1, and so on, tile -2, tile -3, and so on and so forth. So here we are just getting the number from this string. Okay, and I'm just going to copy one more line. So here in this line we are going to set on the my map, we are going to get the child based on the tile index. We are getting it on this line, so tile index, that set color to highlight color. I'm just going to create this highlight color here outside, I mean in the global scope under the load PRC file data. So highlight, and let me see if it is working or not. I'm not sure yet. So let me run it. Okay, so now as you can see, as I'm hovering over, it paints the tiles to green. Okay, so I'm just going to add one more member variable to the isometric init method, and I'm just going to name it like this, self.hit, and this will be a boolean. It will starts with false. And in the mouse task, I'm just going to copy and paste an if condition. So every time when the hit is not false, so hit starts with false, and every time when the hit is not false, we are going to set on the my map that get child on the hit at the hit index, and we are going to set the color to white. And I'm also going to just copy and paste a white color from my second monitor and just going to paste it here. So this will be the highlight color, so red, green, blue, and alpha, and this will be the white color 1 1 1 1, red, green, blue, alpha, and red, green, blue, and alpha. Okay, and where we was. So here in every frame we are going to ask if the self.hit is not false. In that case we are going to set the my map get child hit index, but we also have to set the hit. Yeah, we are going to set the hit after this line. So we are setting the highlight color, and now we are setting the self.hit to tile index. So it will be no more false, but it will be 0 or 1 or 2 or 10 or 15 or something like that. So, and here when we are getting from the MyMac.getChild at the hit index, we are setting its color to the white and setting the hit back to false. Okay, I know a little bit complicated, but that's how I figured this out. Yeah, okay, so let's try it. Okay, I'm just going to comment out this debug draw for the collision ray. And now, as you can see, as I hover over with my mouse, it detects on which tile I am hovering. So it works as expected. And okay, so this code will be also uploaded to GitHub, so you can just download it and try it out yourself, and I don't know, just play with it as you wish. So the next thing what I'm going to do, I mean in the next section, I'm just going to add that cube here, and we are going to add that isometric movement on this on this grid. So let's just load that box model, and here after the plane I'm just going to copy the following. So cell.cube equals cell.loader.load model, models/box, and this folder is the library folder, so it comes pre-installed with Panda, and also this box file comes pre-installed with Panda. Yep, so you don't have to search it, let's say here in the egg models. You just have to go where your Panda installation is, and you will find that model. Okay, now let's set the cube position. So cell.cube.set position x, y, z. So I'm just going to move back on the y-axis, -1 unit, and also reparent this cube to the renderer. And let me run it. So now on the first tile, the very first tile, we have placed this cube, which will act as some kind of a player character. Okay, so as usual, when we want to move something, we have to add some input events to the application. So here after this hit variable, I'm just going to copy and paste 4 lines, and here we are accepting the arrow left, the arrow right, the arrow up, and the arrow down event. When these events one of these events is happening, we are going to call a self.move method, which doesn't exist yet. We are going to write it soon. So every of these key events will call the self.move, and we are going to pass on which direction we want to move our cube. So arrow left will move the cube to left, arrow right will move the cube to right, and so on. Up will move the cube up, and down will move the cube down. And now let's just create or define that move. So okay, I'm just going to copy and paste this method from my second monitor, and this will be the move method. And as a second argument, it will take a direction. And if the direction equals left, so remember that when we press the left key, it will call the cell.move, and these will be passed as arguments to this method. So left will be passed as direction. So if direction is left, then we are going to set the cube's position to be the cell.cube.get position, so get the current position and add a new vector to it. So when we are moving left, we are going to move it -1 on the x and 0, 0 on the x, on the y and the z. If the direction is right, so we are pressing the right key, we are going to set on the cube the position to the current position, so self.cube.getPosition, plus a vector with 1, 0, 0, vector 3 with 1, 0, 0, so we are moving right. And if the direction is up, so this event is happening, we are going to set on the cube the position to current position plus 0, 0, 1, so we are moving it on the z-axis. And if the direction is down, we are going to set the cube's position to its current position plus the vector 3 of 0, 0, negative 1, and this will move it, negative 1 will move it down, positive 1 will move it up, negative 1 will move it left and on the x-axis, and positive 1 will move it right on the x-axis. Okay, let me see if it is working. So now if I press the right key, it moves the cube to the right. If I press the left key, it moves the cube to the left. If I press the up key, it moves the cube up, and the down key, it moves down. So technically we are seeing this map in isometric view, but this is just still the same. So if I just going to, let's say, comment out these 4 lines, which is the settings for the isometric view, and move the camera back, we still just have a simple 2D grid of planes. So we are still just moving right, left, up, down, and here also just works also the mouse picking. So the easiest way actually to create a isometric view in 3D is just position the camera in position and also rotate the camera to the as I showed you in earlier, so to the correct position. So one more information before I consider this first part finished is many of the or most of the isometric games are using orthographic projection. So now we are seeing our map or isometric map in perspective projection. So if you want to make it orthographic, I added here some comments. So first thing you have to do is actually import from Panda3D core the orthographic lens. I'm just going to do this. So from Panda3D core import orthographic lens, and I already created a video about orthographic projection in my Panda3D tutorial series. So we imported the orthographic lens, and now I'm just going to uncomment these 4 lines. So here in line 66 we are creating an orthographic lens or instantiating an orthographic lens object. Here we are setting the film size to 16 by 9. So this is actually 16 by 9 aspect ratio. So the same as the window. Our window is 1280 by 720. So the aspect ratio is 1280 divided by 720, which is 1.7777, which is the same as 16 divided by 9, so 1.777. So that's why I'm chosen here 16 by 9. Here we are setting the near clipping plane and the far clipping plane for these orthographic lenses. To the near is -50 and the far is 50. And here on this line we are getting the camera node, so self.cam.node, and setting the lens on this node to this lens. And let me see it. And now as you can see we have our map in orthographic projection. So as I said, most of the isometric games are using orthographic projection, but not all. And I will be honest, I like it better when it is in perspective projection like this. So I'm just going to leave it as it is, and here will be the code if you want to use it with orthographic projection. So now that we are finished with the first scene, so with this one, which uses these flat planes, we are going to move to the second scene, second isometric scene, which will use these 3D geometries. And I already typed out the code, and I'm just going to walk you through how I created this scene. So in Blender I created 3 geometries or 4 geometries, and this was just a cube, and I just deleted the inner sides of the cube. I'm just going to show view. So these inner sides is deleted because we are always seeing it from this side. This is the corner piece. And then I created this left piece, which is this geometry. I created this right piece, which is this geometry. As you can see, here is also these sides which are not visible to the camera are deleted. And also I created this top piece, which is just a flat plane. Okay, so if I give to this right piece an array modifier, I will have multiple pieces. Also to this left piece, and also to this top piece. So that's what we are going to do also in the code, but instead of array modifier, we are going to use instancing. So one more thing I did in Blender, I just rotated and placed all the pieces in the center of the world. So this is the corner piece in the center where the XYZ axis are meeting. And also the left piece, I positioned it in the center, also the right piece, and also the top piece. So, and I exported these pieces out individually. So here on my desktop I have here a map, and I exported out the corner.egg, the left egg, and the right.egg, and the top.egg. So 4 individual egg files. And I also just copied these into my project folder inside the egg models. So here they are: corner, left, right, and the top.egg. So these egg files we are going to load in this isometric2.py. So as I said, I already typed out the code for the isometric2.py for this scene, and I'm just going to walk you through the code how I created this one. So most of the code is absolutely the same as in isometric 1, so we are importing all the necessary stuff like the collision traverser, the collision node, bitmask32, also the collision handler queue, the collision ray, and this stuff. Here are the configurations and loading the configurations. Here I also created the white color. So when a tile is not selected or we are not hovering over, we are going to use the white color. And when we are hovering over on a tile, we are going to use the highlight color, which is set to red. So red, green, blue, and alpha, of course. Here in the isometric 2 game class, also inheriting from the show base, and also creating an init method from the isometric 2 and calling the show bases init method, and also setting the background color to pure black. Here the settings for the camera position and rotation are almost the same as from the first scene. The only difference is here in the first scene I moved the camera on the y-axis -6, but here I'm moving the camera back on the y-axis -12. And this is because in the first scene, so these tiles are 1 by 1 units, 1 by 1. But these tiles in the second scene are 2 by 2 by 2, so they're twice the size of as in the first scene. So that's why I had to move in the second scene a little bit the camera a little bit more back. So here is the same. So we are setting the roll rotation for the camera, also the pitch rotation in the local axis or in the local space for the camera to 65 degrees, and also setting the camera's local position to current position plus the vector 3 of -8 on the z-axis. So here we moved it only -4, but here we are moving it -8. Okay, so everything else is the same. Here, loading the 3D models, I'm loading all the 3 pieces I exported out, so the corner.egg, the right.egg, the left.egg, and the top.egg. So all of these, so the corner, the left, the right, and also the top. Here we are creating the map. First we are creating an empty notepad using the cell.render.attach new node, and I'm calling it isomap. So this will create an empty notepad and attach this to the scene graph. And here we are also created a create map method, and the map size will be 10 by 10, so 10 tiles vertically and 10 tiles horizontally. So let me show you the create map method, which is here. So the create map, it also takes 2 arguments, the width and the height of the map. Okay, I also did here a comment. So creates the map using instancing, also sets the into collision masks. So here I am also creating a counter and also 2 nested loops, so for z in the range of height and for x in the range of width. And in every iteration of this inner for loop, I'm creating a tile instance. So by create, I'm in a tile notepad. So self.mymap.attach new node, and the tile's name will be tile-string of counter. So tile-0, tile-1, tile-2, tile-4, and so on and so forth. So, and as I said, we are attaching this node or notepad to the mymap empty notepad we created here, which is the isomap. So, and if x equals 0 and if the z equals 0, it means we are creating this corner. So in this case, we are going to set the tile's position to x, 0, and z. We are going to instance a corner piece to this position where this tile is. And also we are going to set the into collide masks. So tile.find the corner, get the node, and set the into collide mask to bitmask 32 bit 1. And let me show you this corner. If I go back, so here is the corner.egg. If I open it up using Sublime, you will see that it has a group of corner. So here we are getting this group by this star/corner. Okay, so if x is 0 and z is bigger than z, we are going to instance, first we are going to set the tile's position to x, 0 and z times 2, because remember that all of these cubes or of these pieces are 2 by 2 by 2. So that's why here we are using z times 2. And we are instancing a left to the tile, a left piece. And the left is this one, this model. Okay, so we are instancing a left piece, and we are also getting the node that's, or we are setting on the node the set into collide mask to bitmask 32 that bit 1. So let me open this left.egg, and as you can see, it has a group of left. So we are selecting this group. Here it also says vertex pool left. So we can select it like this, tile.find, and select the group. And also when elif x is bigger than 0 and z equals to 0, it means we are going to the right. So in this case we are going to set the tile.position to x times 2, 0 and z, instancing a right piece, and also setting the set into collide mask to bitmask 32.bit 1. So here we are getting the right. And let me open up the right.egg, and as you can see it has a group of right. And lastly, so when x and z are bigger than 0, in this case we are going to set the tile's x position to x times 2, y position stays at 0, and z times 2. So x, y, z. And we are going to instantiate the top piece. And also going to find the top, getting the node, and setting the into collide mask to bitmask 32.bit 1. And let me open up the top.egg file, and as you can see it has a group of top. So this is what we are selecting, this whole group. Okay, and lastly we are just incrementing counter by 1. So every time, as I said here, when we create a tile, we are going to have tile-0, tile-1, tile-2, tile-4, and so on and so forth. Okay, so we created the map, and let me show you if I just going to for a second comment out these 4 lines and run it and move the camera back. Okay, as you can see here, we're just seeing it from straight top down. Okay, so set back the camera's position. Here is the same. We are creating a collision traverser called picker, a collision handler, queue, and also a picker node using collision node. We are setting on the picker node the set from collide mask to bitmask 32. So this is the from collide mask, and here we are setting the into collide masks. Where I left, so we was here, and also we are creating a picker node path from self.camera.attach new node picker node, creating a picker ray from the collision ray. So here we are going to use so-called ray casting. We are going to add to the picker node to add solid a picker ray, and also set the picker.add collider picker node path and cell.queue. And as I said, it's a little bit complicated, but you can also just go to the documentation and learn it there. I think it's overly complicated. This should be I think this should be better simplified, but this is just my opinion. Here I also created a hit called false, which is a member variable to the isometric game class. And here I also added to the task manager this mouse task method. So self.taskmanager.add the mouse task and calling it mouse dash task. So let's go to the mouse task, and here I added check the mouse position and detects mouse hover. Okay, first if the hit is not false, it means we are going to get on the my map the get child at the hit index, and we are going to set the color to white. So this happens if we are not hovering over, everything is white or the default color. And when we hovering over it colors it to red. So, and we are also going to set the hit back to false. This is the same as I already showed you in the first part of the video. So here we are checking if the mouse is inside the window, and if it is true, we are getting the mouse position. with self.mousewatcher_node.getMouse, and here we are casting array. So cast array and traverse the map to detect which tile was hit by the ray. So we are doing this by self.picker array that's set from lens, from camera node lens, and getting the mouse X position and getting the mouse Y position. And also we are traversing the whole map for so that it traverses back the whole map, so where it detects the hit. Okay, so and it creates a queue, and if this queue's entries, so if there is a collision, it means that the get number of entries will be bigger than 1. So in this case, if the get number of entries is bigger than 0, not bigger than 1 but bigger than 0, it means that there is a collision or we are hovering over on a tile. In this case, we are going to sort the entries and do the same as we did in the first part. So just getting the tile using the self.queue that get entry 0, get the int notepad and get the node at index 2. And here I'm just printing out tile.getName, so it will print out the tile we are hovering like this: tile-29, tile-27, tile-15, and so on. So to actually get the index, so the number after the dash, here I'm just casting it to an integer, so tile.getName.split at the dash and getting the first index, which will get the numbers, just the numbers. So here I'm just setting on the mymap, I'm getting the self.mymap the get child, I'm getting the child at the tile index and setting its color to highlight, and also set the self.hit to tile index. So okay, as I said earlier, all this code will be uploaded to my GitHub page, and the link to that GitHub page will be added to the video description, so you can just download it and also modify it however you want. And yes, that's all I think I wanted to show you in this video. Just one more tip: if you want to see your grid in wireframe, you can call the self.wireframeOn method, and it will show your map in wireframe mode, which I think looks very cool. I just wanted to give you this tip. Okay, so these egg models, as I already said, these files and also the egg models and also the texture will be uploaded to my GitHub. And I don't know what topic I'm going to cover next, and also I don't know when, but sooner or later I will upload the next video. And until then, just thanks for watching and have a nice day.